Okay, so once again, good evening everyone. So our presenter able naman to discuss the topic, no? So again, there are some examples, no, on how we'll be able to understand more the data mining. So let's say for example, no, a big supermarket that has a large number of records of customer purchases, no, conventionally, in many supermarket, this data is mostly used for inventory management or budgeting. However, so now by using sophisticated data mining tools and diligently scanning through data to find patterns that were never seen before. So the supermarket management may know which combination of products is mostly purchased by their customer and how seasonality and other factors their purchasing decision. And this is what we term a recommender systems, no? Which is now being implemented to boost sales by recommending products to prevent customer base on their previous purchase activities. Consequently, this increased customer satisfaction. As you may expect, the process can be extremely arduous and time-consuming and may require a high level of acumen to come up with valuable and actionable insights. So going through such a large amount of data when trends might not be obvious could get painful and demotivating. So therefore, learning some useful data mining procedures may prove beneficial in this regard. So you might be wonderful or wondering what benefit you can get out of this technique. So as taught in the data science, no, the data science bootcamp actually, you will improve the prediction and forecasting with respect to your product. An in-depth analysis of trends can offer managers, no, a much more reliable way to conduct planning and forecast. Furthermore, it is also assist them in boosting their decision-making abilities as the decision are evidence-based rather than mere conjectures and intuition. And additionally, this will enable the organization, no, to utilize resources optimally and enhance the customer's experience. No? How mining techniques could be leveraged, no, to fulfill the goals of organization. Okay. So again, our presenter mentioned about the data mining processes. No? So the complexity of the entire data mining mechanism can vary according to the size and kind of data an organization has and the aims that are required to be fulfilled. However, in most cases, there will be a genetic process that underlies all such activities. Now, the domain knowledge, no, the foremost step on this process is to possess relevant domain knowledge regarding the problem at hand. So to anyone looking at a large pile of data, it may seem like a collection of junk, no, unless the person has the background knowledge and information about the company, the organization, or the business itself. Only then one will be able to get a sense of what sort of data they required and what are the relevant properties of data to take into consideration and how that could be used to solve the problem at hand. So once these questions are answered, it will be easy to stay focused, allocate resources properly, and attain a productive result eventually. And this step will guide the discovery method and allow discovered patterns to be expressed in concise terms and the different level of abstraction. When it comes to data collection, after defining the goals in the previous discussion, it is essential to collect data. This could involve using data that already exists in the company database, getting data from external resources, or steps to collect new data through survey forms filed by customers. So a group experts hold this point of view that an organization must collect data as much data as possible. Now, even if it doesn't make sense at any early stage. Now, when it comes to data cleaning and pre-processing, following this collection steps, comes the most onerous step of all. Data cleaning and pre-processing is, in simple terms, These steps involves dealing with missing values and outliers, no, same with our statistics before, no, during our high school, no, and removing noise of or other misleading components that may cause false conclusions. So this also includes transforming data into a form required by the mining procedure, and this step may take a lot of resources, effort, and patience to perform. Now, it is important for us to analyze and interpret. Now, the most crucial part begins by limiting data to most important features and creating new relevant and useful features by leveraging the combination of the existing features in the data. Data is carefully analyzed and using mining algorithms. Hidden patterns are extracted from the data because the models created using these algorithms could be evaluated against appropriate metrics to verify the model's credibility. So the choice of these metrics depends on the nature of the problem. A problem relating to the detection of fraudulent activity might choose false negative errors as a suitable evolution metric. So the pattern discovered after this step are interpreted using various visualization and reporting techniques and are made comprehensible for for other team members to understand. Then after that, we need to deploy. Finally, the insights are used to take action and make important organization or business decisions to solve the problems and leverage the entire laborious process undertaking, because the process is the success of this process can be assessed by how much value it brings to your organization or to your company. So the models used for data mining can be primarily distinguished under two main types, supervised and unsupervised. The former is a term used of models where the data has been labeled, whereas unsupervised learning, on the other hand, refers to unlabeled data. And these models can be further classified as specified in the description, like classifications. Now, so classification, of course, is a form of supervised learning technique where a known structure is generalized for distinguishing instances and a new data. Based on the data, the model will create set of discrete rules to split and group the highest proportion of similar target variables together. So banks use classification to predict if a client is going to default loan payment or based on the client's activities. The next will be the regression. No? Regression analysis is a statistical method for examining the relationship between two or more variables. It is a supervised learning technique used in predictive analysis to find a continuous value based on one or numerous variable. Let's say, for example, the regression algorithm are used by companies to forecast sales in future months based on sales data of the previous month. Another is the anomaly detection, also known as outlier detection. So, according, of course, again, anomaly detection is an unsupervised learning technique that is used to find rare occurrences or suspicious events in your data. The unusual data points may point to a problem or rare event that can be subject to further investigation, because anomaly detection could be used for network security to find external intrusion or suspicious activities from the others. So for instance, a hacker opening connections on non-common parts or protocols. Then clustering. Another unsupervised learning method is the clustering, because clustering is the practice of assigning labels to unlabeled data using the patterns that exist in it. So it assists in finding out structures in data that can group similar data points together. Let's say, for example, clustering is a group of large set of documents into categories based on the content. So what will be the common applications? No? Data mining can be effectively used in marketing, no, to create customer segments based on their purchasing patterns that can be extracted from behavioral analysis. And this could be used for creating targeted advertising that varies according to the customer's profile, and as a result, increases the conversion rate. So, as I mentioned earlier, financial organizations have been using data mining to detect fraudulent transactions. Previous transaction data can be analyzed to extract patterns and find any anomaly that can assist in distinguishing such transaction, because such methods are getting more effective in combating fraudulent activities and anticipating activities that might be atypical and might potentially go unnoticed. So in the area of natural language processing, data mining, or referred to as text mining, can be of extreme use when analyzing a large value of news, social media, or text data. Such data mining techniques have evolved to become contextually aware and can enable us to find out sentiments for a particular product. A firm could use it to understand how the general public feels about their newly launched devices or device. Similarly, it is also assist in discovering topics under discussions amongst the public related to a particular aspect. And this technique is used by detecting fake news or social media as well. That's why if you are watching TVs, YouTube, or even always turn on your Facebook, there are some informations related to Google analysis now, wherein there is a discrepancy between the Pulse Asia survey and the Google, of course, now Google results now. Now, the data mining techniques, of course, is again is a complete data mining training for all actually. Data mining is promising field in the world of science and technology. Again, in data mining, it's just not only pure IT, no? We need to understand science and mathematics at the same time, no? Because data mining, which is also known as knowledge, discovery in database is a process of discovering useful information from large volumes of data stored in database and data warehouses. And this analysis is done for decision-making processes in the companies or even in the organizations. So data mining is carried out using a various techniques such as clustering, associations, and sequential pattern analysis and decision tree. That's why, as I mentioned, it's too important for us to understand the decision trees, discrete structure, data structure and algorithm, and so on. So again, as stated by your presenter a while ago, data mining is a process of discovering interesting patterns in knowledge from large amount of data. So the data sources can include databases, data warehouses, the web, and other information repositories, or data that are streamed into the system dynamically. So maybe somebody asking, why do businesses need data extraction? So let's say, for example, in SM, or even Vikings, or even the TicketNet, with the advent of the big data, let's say, for example, if the game is Ginebra versus Magnolia, Ginebra versus Meralco, how many tickets released? So with the advent of big data, data mining has become more prevalent. Big data is extremely large sets of data that can be analyzed by computers to reveal certain patterns, association, and trends that can be understood by humans. Big data has extensive information about varied types and varied content. Let's say, for example, yung game 4 ng Ginebra and Meralco. Imagine 3 days or 5 days right after game number 3, ticket sold. So nakukuha agad ng TicketNet yung pattern na kapag may laro ang Ginebra, ganito karami nanonood. So therefore, there are certain decisions that okay, we need to increase payment for this area and so on and so forth. So thus with this amount of data, simple statistics with annual intervention would not work. This need to fulfilled by the data mining process. And this lead to change from simple data statistics to complex data mining algorithms. So the data mining process will extract relevant information from raw data such as transaction, photos, videos, plot files, and automatically process the information to generate reports useful for business to take action. Thus, the data mining process is crucial for businesses to make better decisions by discovering patterns in trends in data, summarizing the data, and taking out relevant information. So a while ago, our presenter mentioned about the how to process the data extraction, no, and the data mining. He is also give us a 6 phases, no. We have business understanding, data preparation, modeling, evaluation, and deployment. And when it comes to of course, a while ago he mentioned about the data mining methodology, no, developed by SAS, no, the SIMA, no? Sample, explore, modify, model, assess. Kaya SEMA. SEMMA. Sample, S, E, explore, modify, model, kaya MM, and assess. No? So this is another data mining methodology developed by SAS Institute. No? SEMA makes it easy to apply exploratory statistical and visualizes techniques or visualization techniques, select and transform the significant predicted variables, create a model using the variables to come out with the result and check its accuracy. No? So a while ago, our presenter shared about the steps in data mining process. So the data mining process divided into parts. No, again, data pre-processing and data mining. No? So data pre-processing involve data cleaning, data integration, data reduction, and data transformation. So the data mining parts perform data mining, pattern evaluation, and knowledge representation of data. So there are many factors actually that determine the usefulness of data such as accuracy, completeness, consistency, timeliness, and the data has to qualify if it satisfies the intended purpose. Thus, pre-processing is crucial in the data mining process because the major step involved in the pre-processing are data cleaning, no? As what our presenter mentioned, data integration. So data integration with multiple heterogeneous data sources such as databases, data cubes, or files are combined for analysis. This process is called data integration. This can help in improving the accuracy and speed of the data mining process. Now, different databases have different naming convention of variables by causing redundancies in the databases. So additional cleaning can be performed to remove the redundancies and inconsistencies from the data integration without affecting the reliability of data. We have also data reduction. No? This technique is applied to obtain relevant data for analysis from the collection of data. So the size of the representation is much smaller in volume while maintaining integrity because data reduction is performed using methods such as naive Bayes, decision trees, and neural networks, and others actually. No? So some stages of data reduction are, as what our presenter mentioned, dimensionality, numerosity, data compression. Under data transformation, this will be the process actually that data is transformed into from suitable or into a form suitable for the data mining process. Data is consolidated so that mining process is more efficient and the patterns easier to understand. So data transformation involves data mapping and code generation process. Strategies for data transformation, of course, is smoothing, aggregation, normalization, and discretization, like age, no, or gender, and so on. Then under data mining, okay, pattern evaluation, knowledge representation. Okay, so knowledge representation is a step where data visualization and knowledge representation tools are used to present the mined data. Data is visualized in the form of reports, tables, and others. For pattern evaluation, these steps involves identifying interesting patterns representing the knowledge base on the interestingness measures. So data summarization and visualization methods are used to make the data understandable by the user. So actually, data mining process in Oracle DBMS, no? I think in the market, especially today, majority of the company used an Oracle because Oracle use RDBMS, no, related database management system, which represent in the form of tables with rows and columns. No, pag rows, horizontal. When you say columns, vertical. Data can be accessed by writing database queries. No, but related database management system or the RDBMS, such as Oracle support data mining using CRISP-DM, and the facilities of Oracle database are useful in data preparation and understanding. No? Oracle supports data mining through a Java interface, programming language or SQL interface, automation or automated data mining, SQL functions, and graphical user interfaces. No? So data mining process and data warehouse, of course, a data warehouse is modeled for a multi-dimensional data structure called data cube. And each cell in a data cube stores the value of some aggregate measure. So data mining is multi-dimensional space carried out in OLAP style. No, maybe I think somebody will be able to discuss about the OLAP, no, the online analytical processing, where it allows exploration of multiple combination of dimension at varying level of granularity. So there are some list of areas where data mining is widely used, no, like financial data analysis, retail and telecommunication industries, science and engineering, intrusion detection and prevention, and recommender system. So actually, there are a lot of challenges, no, in data mining. No? Data mining needs large database and data collection that are difficult to manage. No? Paglaki ng database, pagdami na, ang hirap talaga i-manage. Because the data mining process requires domain experts that are, again, difficult to find. Integration from heterogeneous database is a complex process. The organizational level practices need to be modified to use the data mining results. Restructuring the process requires effort and cost. Again, data mining is an iterative process where the mining process can be refined and new data can be integrated to get more efficient results. Because data mining meets the requirements of effective, scalable, and flexible data analysis. It can consider as a natural evaluation of information technology. As a knowledge discovery process, data preparation and data mining tasks complete the data mining process. Because the data mining process can be performed on any kind of data such as database data and advanced database such as time series and others. Because the data mining process comes with its own challenges as well. Okay, now, how about the application of data mining? No? Our presenter also shared about the application of data mining. Data is a set of discrete objective facts about an event or a process that have little use by themselves unless converted into information. So we had been collecting numerous data from simple numeric measurement and text document to more complex information such as spatial data, multimedia channels, and hypertext documents. Nowadays, large quantities of data are being accumulated. So the amount of data collected is said to be almost doubled every year, especially in Facebook, no, in YouTube, and so on. And extracting data or seeking knowledge from this massive data, data mining techniques are used. So data mining is used in almost all places where a large amount of data is stored and processed. Let's say, for example, banks. No? Banks typically use data mining to find out their prospective customers who could be interested in credit cards, personal loans, or insurance as well. Since banks have the transaction details and detailed profiles of their customers, they analyze all this data and try to find out patterns that help them predict that certain customers could be interested in personal loans and others. And basically, the motive behind mining data, whether commercial or scientific, is the same. The need to find useful information and data to enable better decision making or a better understanding of the world around us. So a while ago, no, extraction of interesting information or patterns from data is a large databases known as data mining. No? So data mining or knowledge discovery in databases is the non-trivial extraction of explicit, previously unknown, and potentially useful information from data. Technically, data mining is a computational process of analyzing data from different perspective, dimension, angles, and categorizing or summarizing it into meaningful information. Again, data mining can be applied to any type of data. Data warehouses, transactional databases, relational databases, multimedia databases, spatial databases, time series databases, and of course, the World Wide Web or the internet. So data mining provides competitive advantages in the knowledge economy. It does this by providing the maximum knowledge needed to rapidly make valuable business decisions despite the enormous amount of available data. Okay? There are measurable benefits that have been achieved in different applications are from the data mining. So again, scientific analysis, intrusion detection, business transaction, market-based analysis, education, research, healthcare and insurance, transportation, financial and banking sectors, as I mentioned. Now, the last topic, of course, is the ethical, security, legal, and privacy concern of data mining. Data mining is powerful new technology with great potential to help companies focus on the most important information in the data they have collected about the behavior of their customers and potential customers. It discovers information within the data that queries and reports can't effectively reveal. So the amount of raw data stored in a corporate database is exploding from trillions of point-of-sale transaction and credit card purchases to pixel-by-pixel images of galleries database are now measured in gigabytes and terabytes. Raw data by itself, however, does not provide much information. In today's fiercely competitive business environment, companies need to rapidly turn these terabytes of raw data into significant insights into their customers and market to guide their marketing investment. Because data mining or knowledge discovery is the computer-assisted process of digging through and analyzing enormous set of data and then extracting the meaning of the data. So the data mining tools predict how behaviors and future trends, allowing business to make proactive knowledge-driven decisions. The data mining tools can answer business questions that traditionally were too time-consuming to resolve. They score databases for hidden patterns, finding predicted information that expert may miss because it lies outside their expectations. So data mining derives it from the similarities between searching for valuable information and a large database and mining amounted for a vein of valuable ore. Both processes required either sifting through an immense amount of material or intelligently proving it to find where the value resides. So frequently, the data to be mined is first extracted from an enterprise data warehouse into a data mining databases or data mart. So the data mining databases may be a logical rather than a physical subset of a data warehouse. Now, there are some ethical concerns of data mining. No? The use of data mining, especially data about people, and we know and we are aware that our Philippine government releases and extensively monitored and of course applied the Data Privacy Act of 2012. This will be a serious ethical implications of a data mining. Companies face an ethical dilemma when even deciding if the company should make a person aware his or her information is being stored for future data mining. By giving a person the option to opt out of data collection, a company can hurt its competitive advantage in a marketplace. Because a company must decide if a lack of ethical concern will cause a loss in a good will from customers and suffer from a backlash from the company's consumer. Because companies who use data mining technique must act responsibly by being aware of the ethical issues that are surround their particular application. They must also consider the wisdom in what they are doing. Let's say, for example, data mining sometimes can be used to discriminate people, especially regarding racial, sexual, and religious orientation. Maybe you are also aware with regards to the how do you call this one? The support, no, of Iglesia ni Cristo in BBM Sara. No? Because the use of data mining in this way is not only considered unethical but also illegal. Individual needs to be protected by or protected from any unethical use of their personal information. And before they make any decision to provide their data, they need to know how this information will be used, why it is being used, what parts of the information are going to be taken, and what consequences this action will have. So by doing this, individuals will inform and told straightforwardly about the reasons and consequences of using their information. Because ethical concerns in data mining can be seen in two main ethical themes, and this relate to privacy and individuality. So as I mentioned earlier, the wrong use of data can cause people to fall in unethical issues, which are also considered illegal. So the importance of privacy and individuality has to be valued and believed protected to make sure that people are treated reasonably. People should be conscious of the significance of the threats and dangers and constantly discuss these ethical issues. Experts consider data mining to be morally neutral, or on the other hand, the way that this data is being used may come up with questions and concerns about ethics. Data need to be used in the right purpose to make sure people are safe. So again, security concerns on data mining. Data mining is the process of creating a sequence of correct and meaningful queries to extract information from large amounts of data in the database. As we know, data mining techniques can be useful in recovering problems in database security. However, with the growth of development, it has been a serious concern that data mining technique can cause security problems. No? A lot of security experts see data mining as one of the most primary challenges that consumers will encounter in the next decade, because the definite complexity in data mining is building up accurate models of data analysis without giving the right to use the information in specific customer records, which will secure the database, no, from being used the wrong way. Developing such models can reduce the security issues that user may face, because security problem is in data mining are one of the most popular concerns, because of the fact that when using data mining, individuals are usually working with large amount of data or informations. No? So, and they can have access to it easily. This is dangerous if this data was not used in a secure way. So, as data mining guarantees to open up lots of new fields of extracting information from both old database and future database that may be developed with data mining as a support purpose. No? So, the data mining session in some large companies suggests that there can be serious security issues in data mining. While saying this, it is not recommended that the data mining should be eliminated. However, it is to mention security as one of the important aspects and issues that should be judged and addressed. Again, data warehousing or data warehousing companies must monitor who has access to the data within and what parts of the data warehouse they have access to. An example of a company that allows restricted access to their data warehouse for data mining purposes, let's say, for example, is the Walmart. Walmart has a very extensive database of all their stock, stores, and collected data. Companies that have products and carried by Walmart are allowed into Walmart's databases, and this allows these companies to mine this data for information regarding the sale of their products. So by restricting the accessibility of these companies to just the products offered by the companies, Walmart shows that it is aware that the concerns for security and privacy when it comes to data mining. And the last, of course, is the legal and privacy concern of data mining. So in data mining, the privacy and legal issues that make result are the main keys to the growing conflicts. So the way in which data mining can be used is raising questions regarding privacy. Every year, the government and corporate entities gather enormous amounts of information about customers, storing it, no, in the data warehouses. Part of the concern is that once data is collected and stored in the data warehouse, who will have access to this information? Oftentimes, ang consumer may not be aware that the information collected about him or her is not just shared with who collected the information. With the technologies that are available today, data mining can be used to extract data from the data warehouses, finding different information and relationship about customers, and making connections based on this extraction, which might put customers' information and privacy at risk. So data mining necessitates data arrangement that can cover consumers' information, which may compromise confidentiality and privacy. Okay, so again, data mining necessitate, of course, again, which compromise confidentiality and privacy. One way for this to happen is through data aggregation, where data is accumulated from different sources and placed together so that they can be analyzed. So companies such IBM are working on methods of mining data that will allow for complete individual privacy while still creating accurate models of data. So IBM Methods has developed a method called privacy preserving data mining. So by randomizing a consumer personal information before it is ever transmitted using IBM's privacy preserving data mining method, a company can still gather the information it would like when not impeding on its customers' right and privacy. Because actually, the steps or the process of the IBM or the International Business Machine Company, it is logical that that a lot of companies and governmental agencies need to use data mining as a part of their jobs. But the hesitation if this information is being used the right way. For example, data mining can be helpful for some companies in order to target the right market. So in the technological and the informational age, it looks like the process of getting data about customers and employees is getting a lot easier than it used to be before. So the quick transfer of personal information has resulted to identity theft risk. So privacy concerns are becoming an important issue in data mining because of the risk behind it. Especially that many of the consumers who buy products or services are not conscious of data mining technologies. Okay, so I'll just want to share a video presentations related to what I'm of course discussed.
Sir, stop share na po ako, sir.
Sure.
Thank you po, sir.
Look at data mining is, and we're going to introduce some fundamental concepts we need to understand how it works. Informally, you can think of data mining as the process of using a computer program, an algorithm, to find patterns or relationships in your data. For example, you might want to be looking for what combinations of symptoms will allow you to reliably diagnose a patient. Another example of data mining, if you are someone who is running a store, you might want to know what types of products customers tend to purchase together. At the heart of the data mining process is some type of machine learning, in which we apply an algorithm that learns something about the data. And these are called machine learning algorithms. Ultimately, we're going to look at 3 different types of machine learning in this class. But for now, we're primarily going to focus on classification learning. So in classification learning, we're trying to figure out how to classify objects or entities on the basis of their characteristics. So maybe you know a bunch of information about a customer of your store or potential customer, and you're wondering whether that customer is likely to buy a computer in the course of the next year. You just want to be able to have a pretty good idea. Yes, they are going to buy it. No, they are not going to buy it. And so what you need to do in order to perform classification learning is you need to have what is called training data, a set of training examples where each example is a single customer in this case. And we have a bunch of information about the customer. We have the customer's ID, the gender, the age, whether the customer is a student, what the customer's credit rating is, good, fair, excellent. And then, this is the important part, we already have classified each of these examples. We already know whether the customer bought a computer or not. And the idea then is that the algorithm is going to take this training data and produce a model of some type that we can then use to classify new examples, to predict, in this case, whether a new customer will buy a computer in the next year. One possible model you could learn from these training examples, and by the way, I've only shown you 5 customers. You want as much training data as you possibly can get. But one possible model that might be produced is what is known as a decision tree. And this is based on our training data. The actual process of finding the tree, determining the tree, is something we're going to get into later. But once we have learned the model from the training data, we're then able to use it to classify new examples. So here I have 2 new customers. I know the same information about them as before, except I do not yet have a classification for them. I don't know whether they're going to buy a computer, and that's what I want to be able to predict. So to apply my decision tree, I'm going to start at the top and work my way down. So if we focus first on the first customer, ID 333, you can see we're being told to look first at her age, and you can see that she's 68, and as a result, we're going to go down the branch that is labeled greater than 65. Because her age is greater than 65, we go down that branch. That brings us to the next thing that we should look at, which is her credit rating. And because her credit rating is fair, we're going to go down that branch, and that brings us to a box with a classification. And in this case, that box tells us that no, we should not expect her to buy a computer. That's our prediction for that customer. Let's go to our next customer. We again start at the top. This customer's age is 23, so we go down this branch, which is the less than 35 branch. By the way, notice there's a middle branch here for customers whose ages are between 35 and 65. But in this case, we're going down this branch. That then tells us to look next at whether the customer is a student. And in this case, the customer is a student, so we go down the yes branch, and that brings us to our classification for that customer, which is yes, we predict that he will buy a computer in the next year. Now, when we're talking about our training data, every row is referred to as an example or an instance. Every column is referred to as an attribute. And we can divide up those attributes into 2 types. The output attribute is the one that we're trying to be able to predict. That's our classification column. Everything else is an input attribute. The model that we learn takes the values of the input attributes and gives us a value for the output attribute. In the case of our decision tree, it took the values of the age, student, and credit rating columns, and it gave us a prediction for whether the user would buy a computer. Buy computer was our output. Now, another way to distinguish between the attributes is on whether they are nominal or numeric. Nominal attributes have values that are essentially names of categories. In this case, most of the attributes are nominal: gender, student, credit rating, and buy computer. Numeric attributes, as you might expect, have values that are numbers. But what's especially important here is it has to make sense to compare those numbers using greater than and less than. So for example, in our model, we were basing our predictions in part on things like, was the age less than 35? And that kind of comparison makes sense because it does make sense to say whether someone is less than 35, and that might have an impact on your predictions. But for something like ID, even though the values are numbers, that's not truly numeric because it wouldn't make sense to base your prediction on something like whether the ID was less than 300. That doesn't give us useful information about the person. In order for us to apply classification learning, we have to have a single output attribute whose value we're trying to determine. So in our case, we did. And then the other thing that made this classification learning is that that single output attribute is nominal. For classification learning, that has to be the case. The thing you're trying to predict has to be a nominal attribute. And the input attributes can be either nominal or numeric. There's no restriction there. Now, let's imagine we change the problem. So instead of predicting yes or no, we're trying to predict a probability that the computer will be bought by the customer in the next year. Well, now our output attribute is numeric, and therefore it can't be classification learning anymore. Instead, it's now numeric estimation. And this has a completely different set of algorithms, and it produces different types of models. And we'll talk more about this later on. It's worth noting that here again, the input attributes can be either nominal or numeric. What matters is that the output attribute is numeric. And if it is, you have to do numeric.
Okay, I think that was an example of a data mining fundamentals, no? This time I just want to share about data mining process, no?
Hello and welcome to this quick session on data mining versus process mining, the differences and how we can use them within an Ariba environment. As I've covered in my previous video, what you can see in front of you here is Cloud for Analytics, and essentially this is a tool which we can use to look at data, drill down into it, and get insights from that information. And this is really what we call data mining. So essentially how to change things, how to go into them, filter, get more information, actually go down, putting the data in different ways and getting insights into that information to see different data in different ways from the system. So that's really what we call data mining. How do we actually get insights and information from that, either automatically if you're using some of the artificial intelligence tools, or of course just by manually drilling down into information backwards and forwards, cutting it in different ways, so on and so forth. So that's data mining. How do we mine our way into data to get insights from it? The other side of things is what we call process mining. Now, process mining is a similar concept, but as opposed to taking data and drilling down into it in an analytical way, is to look at the various activities and connections that bring the data together. For instance, if we look at a procure to pay process, we have a purchase order, receiving goods, scanning the invoice coming in, paying the invoice, and an end of the process. So very basic P2P type process coming through. But what we can also do here is look at all the different activities that take place as subsections of that process. If I zoom in using my process mining tool, in this case a tool called Solonis, what we can start to see here are the different elements and the different records that are actually going through different parts or different activities. So I can see in this particular case, I have to remove a payment block 8,400 times from 97,000 processed invoices and purchase orders coming through the system. I can also see that some of these don't work and I have to go back and receive the goods before I can try and put the invoice in the system. So different activities can show me what's actually happening in the data. If I just want to look at different areas, I can see that 16,000 of my purchase orders had to be approved before they went through. So pretty interesting. All this data is actually coming from the various tables, in this case in an SAP environment, but of course we can take them from any ERP environment and link the data together. And what this is allowing me to do is to drill down on the process or mine the process so I can see where the processes are not working as they should. So these are the activities that are taking place. In this case, I've had 5,000 price changes, so on and so forth. And I can see where things are happening, or should say, not happening as they should. Only got 20 reverse invoices, that's not too bad. So that's a good result. Anyway, so we can look at the different processes. What we can also do, however, is look at the connections that are occurring within the data itself. Following a document from point to point. And this is where things can also get a little interesting. So I can see that 10,700 of my invoices that started to be created basically got deleted because the process ended there. 14,000 went straight to invoice before they got received. So some odd things happening in there. And we can start to look at where the connections happen and where things are not happening as they should. Here we can take it down to more and more levels. And ultimately, if I actually expand this all the way for all activities and all connections, you can start to see all the different elements that can possibly be involved in processing purchase orders. As you can see here, there are quite a lot. So that's just one way of looking at this in terms of what are the different activities and connections and what are the processes, or how many activities I should say, are going through those processes. Another way of looking at this is to actually take the data, and this will just take a few moments to actually analyze this data for me, and view it almost as a movie over time, taking all of the different activities and seeing how many times a case runs through that activity. Now, what I mean by cases, in this case at the bottom, you can see all the different purchase orders that are flowing through the system, and obviously the dips are usually during night time. Let me just forward this to a busier period. And what we'll start to see now is in the process, as the purchase orders start, we can start to see where the bottlenecks appear over time in that actual process. And of course, I can speed this up a little bit so we can see what's happening over time. So what this allows me to do is, if I just zoom in a little, I can see where processes are taking time to achieve and also where my bottlenecks within my organization are. I can also see, as well as just the number, of course, I can also see the ones which are not following the correct process and actually going backwards in some cases, depending on what the actual activity is that they're doing. So over time, if I just zoom in a little bit more, maybe add a little more detail here, what we'll start to see over time is some of these processes starting to happen, and obviously the end process happening there. And if I speed this up, what we can see is most of the documents are going through the correct process. That's great. But there are still quite a few not doing that, and obviously we can see those happening over time. So this is what we call process mining as opposed to data mining. Looking at a process, where are the bottlenecks, how are things occurring within the organization, or where are things occurring as they shouldn't be occurring, and how are actual activities happening across the data. Now, just for interest's sake, if I just have a look into some of the other tabs here, what we've done is actually taken some of this data straight from, in this case, an SAP ERP system, and we've just downloaded the tables, and some of you familiar with data tables in SAP can see some of the data table names there, and brought those across into here so we can get the information and do that data mining. So this isn't live data. That's not what it's about. It's about taking the processes and how do we actually see those happening. Where is the value in terms of how many different things do we have to do over time? Where are our bottlenecks, and how can we improve our process? And that's what my apologies. That's what process mining is all about. And there we can see the difference between data mining and process mining. Thanks very much.
Okay, so this time I'll just want to share to you the data mining application demonstration and example.
Warm welcome. Today you will see top 13 data mining application and its uses in real world. Data mining is widely used in diverse areas. There are number of commercial data mining systems available today, and yet there are many challenges in this field. In this video, we will discuss the applications and uses in real world. Number 1. E-commerce. E-commerce is one of the real-life applications of data mining. E-commerce companies are like Amazon, Flipkart, Myntra, etc. They use data mining techniques to see the functionality of every product in such a way that which product is viewed most by the customer, also what they also like other. Number 2. Financial analysis. The banking and finance industry relies on high quality, reliable data. In loan markets, financial and user data can be used for a variety of purposes like predicting loan payments and determining credit ratings. And data mining methods make such tasks more manageable. Classification techniques facilitate separation of crucial factors that influence customers' banking decisions from the irrelevant ones. Further, multidimensional clustering technique allows identification of customers with similar loan payment behaviors. Data analysis and mining can also help detect money laundering and other financial crimes. Number 3. Telecommunication industry. Expanding and growing at a fast pace, especially with the advent of internet, data mining can enable key industry players to improve their service quality to stay ahead in the game. Pattern analysis of spatiotemporal databases can play a huge role in mobile communication, mobile computing, and also web and information services. And techniques like outlier analysis can detect fraudulent users. Also, OLAP and visualization tools can help compare information such as user group behavior, profit, data traffic, system overloads, etc. Number 4. Intrusion detection. Global connectivity in today's technology-driven economy has presented security challenges for network administration. Network resources can face threats and actions that intrude on their confidentiality or integrity. Therefore, detection of intrusion has emerged a large crucial data mining practice. It encompasses association and correlation analysis, aggregation technique, visualization, and query tools which can effectively detect any anomalies or deviations from normal behavior. Number 5. Retail industry. The organized retail sector holds sizable quantities of data points covering sales, purchasing history, delivery of goods, consumption, and customer service. The databases have become even larger with the arrival of e-commerce marketplaces. In modern day retail, the data warehouses are being designed and constructed to get the full benefits of data mining. Multidimensional data analysis helps deal with data related to different types of customers, products, regions, and time zones. Online retailers can also recommend products to drive more sales revenue and analyze the effectiveness of their promotional campaigns. So, from noticing buying patterns to improving customer service and satisfaction, data mining opens many doors in this sector. Number 6. Education. Education is an emerging trending field nowadays. It concerns knowledge discovery from educational data. The main goal of this application is to study or identify the student's behavior pattern in terms of future learning, effects of study, advanced knowledge of learning, etc. These data mining techniques are used by institutions to take accurate decisions and also predict appropriate results. Moreover, the prognosis of students' career paths and presentation of data would become more compatible with effective analytics. In this manner, data mining techniques can help uncover the hidden patterns in massive databases in the field of higher education. Number 7. Energy industry. Big data is available even in the energy sector nowadays, which points to the need for appropriate data mining techniques. Decision tree models and support vector machine learning are among the most popular approaches in the industry, providing feasible solutions for decision making and management. Additionally, data mining can also achieve productive gains by predicting power outputs and clearing price of electricity. Number 8. Spatial data mining. Geoinformation systems, GIS, and several other navigation applications make use of data mining to secure vital information and understand its implications. This new trend includes extraction of geographical environment and astronomical data, including images from outer space. Typically, spatial data mining can reveal aspects like topology and distance. Number 9. Biological data analysis. Biological data mining practices are common in genomics, proteomics, and biomedical research. From characterizing patients' behavior and predicting office visits to identifying medical therapies for their illness, data science techniques provide multiple advantages. Some of the data mining applications in the bioinformatic fields are semantic integration of heterogeneous and distributed database, association and path analysis, use of visualization tools, structural pattern discovery, analysis of genetic networks and protein pathways. Number 10. Other scientific applications. Faster numerical simulations in scientific fields like chemical engineering, fluid dynamics, climatic and ecosystem modeling generate vast data sets. Data mining brings capabilities like data warehouses, data pre-processing, visualization, graph-based mining, etc. Number 11. Manufacturing engineering. System level designing makes use of data mining to extract relations between portfolios and product architectures. Moreover, the methods also come in handy for predicting product cost and span time for development. Number 12. Criminal investigation. Data mining activities are also used in criminology, which is study of crime characteristics. First, text-based crime reports need to be converted into word processing files. Then the identification and crime machining process would take place by discovering patterns in massive stores of data. Number 13. Counter-terrorism. Sophisticated mathematical algorithm can indicate which intelligence unit should play the headliner in counter-terrorism activities. Data mining can even help with police administration tasks like determining where to deploy the workforce and denoting the searches at border crossings. So this is the very important video of data mining applications and its uses in real world. Thank you for watching this amazing video.
Okay, so the video discussed the different application of the data mining at present. Then of course this time I'll just want also to share about the data mining on ethical issues, which is too important because again today our government agency, especially the National Privacy Commission, implemented the Data Privacy Act of 2012. So we need to be, we need always to consider the Data Privacy Act, the secrecy or the data privacy of information, and we need to be keep abreast with different sanctions, even the penalties, with regards to data privacy. And today, using different platforms, especially the social media, so try to limit, as what they say, think before you click,
This presentation first looks at what we mean by data mining and data mining on the web. We tackle obvious but necessary questions such as why do data get mined? How is data mining done on the web? What kind of data gets obtained and tracked? We compare in broad strokes the difference between web data mining and magazine data mining to understand the significance of web in data mining practice. Finally, we summarize privacy issues that are presented by the types of data mining being done and propose some ideas on how the future can be better for all parties. Ben Wall and Royaker say that data mining is the process of extracting previously unknown information from data, which can, in the right context, lead to knowledge. Some other scholars, Kasala, Blockhill, and Naveen, define web data mining as the whole of data mining and related techniques that are used to automatically discover and extract information from web documents and services. Marketers say data help them understand and build their customer profiles. With this kind of marketing intelligence, they have the ability to market more effectively, which results in users receiving only marketing messages that are relevant to them. Search engines are also heavy data miners as they use them to better their search results. Cookie technology is one way this is being done. The website you visit sends a cookie, which is a string of code, and your computer stores it in your hard drive so that the website can identify you and record your data. What kind of data can these websites and companies obtain about you? Well, among many, they can know the country and location, the date and time of the visit, because this information is available to them automatically from your computer's IP address. If a site requires you to register, typically ask for your name and an email, and that gets on their database. With cookie technology, the frequency at which you visit or use the website can also be known. This kind of data is usually then anonymized, aggregated, in order that they do not identify you as a person, only as a frequent visitor of, say, YouTube. Why does this practice stir privacy issues? To understand the potential privacy issues that have arisen with the internet, it helps to see how other media have obtained and processed audience data. For example, a magazine distributes a survey filled out by a reader of his reading habits, likes and dislikes, and other pertinent information. The survey gets collated and interpreted, and then shown to advertisers, who then can decide whether the magazine's audience is their target audience, and whether the cost of advertising can still be substantiated. The reader gets to enjoy the content of the magazine at a minimal cost, because advertisers help to set off the cost of producing and distributing the magazine. Sounds simple, right? Web users also enjoy the free services available to them, much like TV or newspapers and magazines. There's nominal or no fees to read and use the websites. Advertisers basically pay much of the cost involved in producing the content and distributing it. Web users also like the convenience of not having to specify their preferences or their username and password every time they use a site. Service providers want their consumers' information to better their service by recommending things that they will use, and to sell their consumers to advertisers. So far, everybody benefits from this model. The problem is, unlike the model in television and magazines, web users may be subject to much more than just their demographics. They also could be giving information that they're not aware of. For instance, in YouTube privacy notice, it says that YouTube may record your usage of the site, including other users you communicate with, and other information you click on while you are in YouTube's environment. It also says they use technology to track who you are so that they can detect that it is you using the site, and you don't have to re-enter your information. But it also means that they can keep track of what kinds of ads you've seen and clicked. Proponents of data mining on the web think there's nothing new about it, since data mining has been here all along. But there are differences between then and now. Surveys are active retrieval of the information or active feedback mechanism, and now this is being done in the background, most of the time without the explicit consent of the user. Various scholars have noted that even when bits of data do not violate privacy, when combined and aggregated, they can take on a new dimension and identify the individual even when parts are non-identifiable information. Other observers also call for privacy laws to not only meet legal requirements but ethical standards, because we know that what is legal may not always be ethical. Additionally, privacy policies on websites are often inadequate. When it says quote-unquote third parties, what do they mean? Is YouTube a third party of Google, since they're owned by the same company? The business landscape is such that many companies are subsidiaries of larger conglomerates, so it begs the question, What do they mean by a third party? Many of these possible third parties are not disclosed on the privacy policy itself. Privacy policies also state that they can be changed without notice. Any usage of the website is considered an agreement to those terms and conditions. Finally, legal language can be difficult to understand, even if a user is prompted to click on agree before they use the web service. By the way, who owns this usage information? Users or companies? Can users withdraw consent at any time? Of real ethical concern is the increasing usage of the internet for health and financial services. Advocates cite the threat of inappropriate data collection by the government, because now that data is obtainable from private companies who survey and use this data. These questions guide and perplex many privacy advocates and internet companies. To improve current practices, it helps to pursue ongoing debates between marketers, advocates, the FTC, and big players, like search engines and content providers, to discuss the rate and effectiveness of self-regulation compared to more government intervention. Users should also take responsibility in increasing awareness in how to protect their information and privacy. They should demand better infrastructure to give them better control over personal data that can be obtained.
Okay, so again, that this will be the discussion of our module number 2. So we need to consider that the privacy concern are becoming an important issue in data mining because of the risk behind it, especially that many of the consumer who buy products or services are not conscious of data mining technology. So as what you can know, every time that you buy, let's say, just not only buy, anytime you visited, let's say, in your social media account on car, so anytime you open your social media account, it displayed a lot of sales about car, the way on how you'll be able to avail car. Let's say you are interested in condominium. So once you open once again your social media account, it automatically displayed different types of car, a different way on how you'll be able to avail car, loan, and so on and so forth. This is also considered a best example of a data mining. Okay, so